Hey, Mohammed, my man, how are you? Hey, I'm good, my brother. What's happening? I don't know, man, because right now I have a class, and then after the class, I have a prac. I have a prac with those students, the EC group. So I think maybe what time did you say is available? Yeah, you you know what we can do? Um, let's talk around because I have a class now. Because you're gonna have a prac too in the labs there, isn't it? Okay, all right, guys. Good afternoon. Good afternoon. How are you? Is it 12 yet? Yeah, it's 12. So it's good afternoon. I hope you're doing well. I hope you're doing well. Here we're gonna do the last of the Mohicans, hydraulic systems. After this, you guys, it's up to you what you want me to do. You say jump by jump. After this lecture, it's up to you. You want the revision, you want what you tell me. You say jump, Sivanda here, I'll jump. Right. I'll be done. I'm finishing with you today. So the rest will be now assessments that we'll be doing. You guys answering quizzes and tests and etc. Revising for the final big major test or exam. And yeah, but otherwise, we're touching on hydraulic systems. Then you guys are gonna tell me when you want a big revision, where we can set out a revision date and we put a few questions for the comrades here to take a look at attack and see whether they are ready to attack the major test. So, but as for today, we're driving the nail home, ladies and gentlemen. I hope those friends of yours who are, please advise them not to bank. These are the lectures that you're not supposed to bank. Let's advise them. Let's send them an email before we start. Comrades, I hope you are holding well. I hope you are keeping well. It is that time. It is that time. Today on these days. These days, lecture is called. Avoid banking by all means. Right. As we were talking, comrades, there's just 29 of us. I wonder where the other comrades are. Because we want to deliver today so that no one can cry foul afterwards. Anyways, comrades, we had a wonderful prac on Wednesday. The other comrades came, we're enjoying ourselves there. They did the prac. Some it worked last minute. But most of the people, no one failed that prac. Everyone who attended the prac passed. Yeah. With the highest going to 80 and some 80%, then the other guys maybe lowest was 65, maybe. Yeah. But everyone passed that prac. It was easy and enjoyable, except for the fact that the other comrades they decided not to come again as usual, you see. So we won't dwell on that, but otherwise those who came we enjoyed. I hope the next group next week is gonna come and we're gonna have a wonderful time, like the comrades that we are around today. I hope we're gonna enjoy too. And with the comrades that come after until we finish, I hope we're gonna have a wonderful time there. And what was the other thing? The comrades seem to be doing fine so far. I'm actually happy with what I'm seeing. I haven't had problems with any of you. This class is actually doing well. I'm happy about the class. I'm really happy. We've been going on so well. The family fights here and there, but otherwise, the progress. I'm happy. People are not failing. People are there. They are showing that they are part of us. So with this class, I'm happy. All things well covered. I hope we finish with a good spirit, like we started with a good spirit there. That would be wonderful. So a reminder that next week we are writing our test two. Before I talk, someone is already, we're talking about the same thing. How wonderful. Great minds think alike, yeah? Say, can you please send us maybe a past exam paper to practice for the upcoming test? There's already a past exam paper online. There's already a past exam paper online. So you don't need many. I was even looking at it right now in front of me. I was browsing through it here, taking a look at how I can hammer you and how I cannot hammer you. But I've seen quite a few similar questions. So that question paper that is uploaded there online, you can also revise using it. But the most important thing, I keep repeating, this is the most important thing I will always repeat. Cover what we do in class. Cover what we do in class. What we do in class first. Understand what we do in class first very well. Make sure what we covered in class. Follow on the lecture notes. Follow on the video links that I uploaded. Rewatch the lectures if you need to. The basics of every exam or every test comes from what you covered in class. That's where the minor things, the minor detail are. Once you have covered what you've done in class, then we can take a past exam question paper and now try to check your understanding of the material. If you find that you are stuck again, go back to the class stuff. If you do that, you will never fail any of my tests or exam. I'll never bring something which we have never seen in class in the major exam. Even in this test, I won't bring something which is ridiculous. It's some things that we've covered and learned about. So the venue, by the way, I announced on an email that I sent to people, and I also sent on WhatsApp. Venue for the test, the department they booked as SU. So the secretary, Miss Nelly, has already booked SU. So during our lecture time next week, we're gonna venture into the SU building. That's where we're gonna write the on-campus test. Campus test. I'm gonna send reminders as usual. Even on Friday, I'll send another reminder, and on Monday, maybe next week, another reminder. Because I realized that some of us they are technology dependent. If ESCOM decides to go or if someone decides to steal their phone, they will come and claim that the robbery. So the reminder was no longer there because, but that's an excuse that you can never use in university. That you forgot to do something because your phone was the one with the reminder. You can only use that excuse if you have some problem with remembering things, of which that's a doctor's thing. But for you to tell us that because you lost your phone, the reminders, all of them were lost, so you didn't come. You will get yourself in trouble if you do that. Because the best thing that I will tell you and advise you in order not to forget things, do it like me, old school. I have a big timetable right in front of me here with all my dates in front of me. In the office, at home, I have another big board also with my timetables. And then also on my laptop, I have another reminder. On my phone, I have PDF reminders also there. On my tablet, I have other PDF reminders. In the car, I can pull out something on the drawer there, on the glove department compartment there. I still have some printed timetables for myself. I'm old school. I have the technology, but with ESCOM problems, technology is not reliable. So be careful, guys, because most of the things don't depend on my human nature to forgive you. I might forgive you and then go get fired up there. When they start asking me now, so and so decided not to do this, you forgave them. Why did you treat them so special when other students came on time and did this? So you're putting me at an awkward position when you come with such excuses, because most of the comrades will do things the right way. Most of the guys here do things the right way. I've seen they follow instructions, do it nicely, and then you now you create a controversy. It will bite you in the end. So guys, don't forget SU. That's where we will be for the test, and this is our last topic. After this topic, we have covered them all. What happens next is up to you, comrades. You can send me an email and tell me, Minera, we're requesting a revision of this topic. Minera will request a revision of questions. I will come on that day, we will revise those things. The test will cover everything from where test one ended. Where test one ended, that's where it will start up to the end of today. What we're going to cover today is going to be part of the test. So material covered after test one is all going to be in the test. So whatever we covered at the end of test one up to what we're going to cover today, that will be part of test two. And our comrades, relax. It's not going to be that hard. It's just going to be like test one, but with less mistakes, because now you will be on campus writing on paper, no multiple choice, so it will be easy. As long as you study the notes, go over everything we did, you will be fine. Don't be late. Don't be late, please. Familiarize yourself with the venue so that you are safe. And Sarah was reminding me yesterday. Was it yesterday? She sent me an email. She was reminding me. I think she thought that I had forgotten what I said on WhatsApp and what I said to the class. Guys, what we wrote that day was a multiple choice test online. So it's set up as a quiz online. Once it closes, you guys all have answered. I cannot manipulate the test marks there. I can't manipulate the marks. I can look at the questions and look at how you answered, but I cannot change the mark on learn. But however, when we're finalizing the marks, taking them to Student Central, I won't forget what we discussed. The evidence is there on WhatsApp, so I will award everything that I promised accordingly. So have no fear on that one. We discussed it and I told people that don't worry, guys, it's my mistake. Yes, the class doesn't will be awarded marks on that one. Yes. And then otherwise, I think so far there are 1 or 4 individuals who have problems. It's because they don't come to class. Those individuals, 1 to 5, 15 who don't come to class, who have problems. But the rest of the class, it's quite a happy performance. And then what else? The issue of practicals, guys, it's written in the course outline. I told you that a prac is a very important day. So if you bank a prac, you are putting yourself in trouble. So I don't know, but I'm just advising as usual that don't put yourselves in those situations because it's hard to get out of them, especially now that there is a 50% of being on campus policy and the 50% of online policy. So such things is going to be hard for you to give an excuse. It's really terrible because you're going to come there, they're going to pull out the policy, and then it's going to be a problem. Even me, as myself, the other class that I'm teaching, they thought maybe things were a joke. That's why I'm saying this class is nice. You guys I'm happy about how you're doing your things. The other class that I'm teaching, the technology class, ETT 121, about maybe a quarter of the class, 3 quarters is okay, about a quarter of the class, they decided to go on holiday and never attend lectures. But now that the semester is over, is about to get over, they started to surface. But unfortunately, we had covered and followed them, and we even called them. And then they disappeared. They decided to come now. They all have a fail already. So you see, there are some things are out of my hands. If I want to forgive you, I can, because the bigger guys there will fire me. So I myself also have to be honest there, otherwise I'll lose my job and go hungry. Anyways, guys, I think we've covered the issue of test one, covered the issue of the venue for test two, covered the issue of the scope of the test, covered the issue of practicals and people who have not booked and those who are banking. Now we can start our lecture. So what are hydraulic systems, guys? Hydraulic systems are the systems that we have seen so far. They are out there in the world. For example, now, these are systems, for example, that you know when somebody is involved in an accident, they bring that machine that comes and cuts the door, right? It cuts the door, etc. That's a hydraulic machine, right? That uses electricity and hydraulics. And then you have seen when you go to Dunlop garages or some other tire changing shops, there is a simple car hydraulic jack system where somebody just with their foot, they step on it and then it pushes the car up. That's a hydraulic system. So the principle of hydraulic systems lies in Pascal's law. What is Pascal's law? Right. Pascal's law says that if you apply pressure in a fluid in a confined space, that pressure is equally distributed throughout the liquid into the holes of that container. Right. So that's what we're mainly going to be concentrating on today. So a hydraulic system, it is a system that transmits energy through the use of fluid pressure. That's by Pascal's law. Right. You must remember this guy because he's the real deal around all these questions. Pascal's law is the major deal. So the major function of the hydraulic fluid is to provide energy transmission through the system which enables work and motion to be accomplished, right? The major function of the hydraulic fluid, right, is to provide energy transmission through the system which enables work and motion to be accomplished. All right. So Pascal's law, guys, it says the pressure applied to a confined liquid is transmitted without loss throughout the entire liquid and the walls of the container. And that is what I was saying before. Let's say you have a container like that, and then you have a piston here that you can press. Here you have your foot pedal. This is the liquid here. They are saying if you apply a force here, right, that force per unit area will become pressure pushing on this liquid. This pressure here will be equally distributed in all directions and on the walls of the container, right? So the pressure applied to a confined liquid is transmitted without loss, no loss, throughout the entire liquid and the walls of the container, right? That's what they are saying there. That's Pascal's law. So take note of this guy and memorize by heart this guy's law, right? Now, this application of Pascal's law leads to this. This guy was, these guys, they were jealous of each other. It's like this guy Newton, if you read books for science, like very well, you'll find out that most of the discoveries that Newton did, it was because of his cleverness or manipulation. If one of the guys discovered something, but they had no money or means to sort out the patents during those times, it was difficult to do a pattern during the old days. People like Newton and the other moneyed ones, they will run and say, right, on your behalf, we'll do this, and then it appears on their name. But the other guys, such as Pascal, which are not for popular like Newton and others. So this guy figured that, if a small force on a small area is applied, it will create proportionally a larger force on a larger area. The only limit to that force which the machine exerts being the area to which the pressure is applied. So what did this guy discover? Was that if you have something like this, this is what we're going to be dealing with. Mostly everything will be like that. Discover that if there is a small portion here, you have a piston there, there is a hydraulic fluid here, right? That's a hydraulic fluid here, right? Hydraulic fluid. And then here you have a bigger area and a bigger piston. Then let's say you can put a car here, right? It discovered that if you apply a certain force here, F1, at a certain cross-sectional area here, area 1 of this piston, you get a certain force F2 going upwards there, a certain area A2 there. So if this force is applied down there, this side, another force will go up, right? But then Pascal said the pressure now applied on this liquid will be equally distributed throughout. So which means that the pressure P1, which is force 1 over area 1, must be equal to P2, which is F2 over area 2, because of Pascal's law, right? So that's what this guy Bramah discovered, that if you apply pressure at a certain small area on a hydraulic fluid, it will transmit that pressure equally without loss through that liquid and the walls of the container. Hence, you will receive a force 2 there per area 2 there, which is equal to P2. Right? So that's what this guy discovered. But basics, before we go too far, basics of remembering. Basics say pressure is equal to force per unit area. Right? That's basics from high school that you should remember. Or from maths, if they cover it, that you should remember. Now, this is what this guy discovered, that if you apply a certain force here, but this thing, that liquid or pressure, which is you found here, P, which will be F over A, will be equal to P2 on the other side, which will be F2 over A2. Right. So then Pascal's law says P1 must be equal to P2. Right. So examples of hydraulic systems, guys, is for example the one that I was talking about, a hydraulic jack, when a car is pushed up just by, imagine your small foot just punching on a certain button there, pressing, and then the car on the other side is suddenly lifted up. How wonderful is that? This was the work of Mr. Bramah, Pascal, right? And then the other thing that we talked about, the example, is the jaws of life. This jaws of life has saved a lot of people's lives, right? The jaws of life is very popular. Jaws of life machine. If you go to YouTube or Google right now and type jaws of life, you will see the machine. This is a well-known practice that is done by grade 8s and grade 9s out there in the schools. They do this one every time. It's never missed the jaws of life. This is through the application of Pascal's law. This is where they use that machine, a hydraulic machine, to cut metal. When car crashes and then the doors are now crushed and somebody can't get out, they bring the jaws of life machine, which is a hydraulic machine. Then it cuts through that metal and then people are taken out. Sometimes it opens metal apart. It acts like a caliper, pulling something apart in that way. Sometimes it's cutting, it's the jaws of life. It cuts a metal to open. It's another example of a hydraulic system, which is Pascal's law or Pascal's principle. So remember, Pascal's principle is the most important aspect here. Once you know Pascal's principle, then you know what that pressure is, force per unit area. The rest is easy. The rest is eating cake. So the components of a hydraulic system are like this. Right, there's what is called the reservoir. The reservoir, the purpose of that is to hold the volume of fluid, transfer heat from the system, allow solid contaminants to cycle and facilitate the release of air. So if we draw it in layman terms, the simplest one which we use for calculations, right, put the liquid there. This tank right here is the reservoir, right? And then there's what is called the pump. The hydraulic pump transmits mechanical energy into hydraulic energy. Right. This is done by the movement of fluid, which is the transmission medium. For example, now you're pushing down there. That's more like you're pumping, right? And then they are called valves. Hydraulic valves are used in a system to start, stop, and direct fluid flow. Everyone knows a valve. A tire is a valve. You press it, air comes in, you open the channel there. So if you have a pressure pump, once the valve is pressed, you can push in air inside. If you don't have a pressure pump, the air inside will be forced down. A valve, you know it. And then there are actuators. Hydraulic actuators are the end result of Pascal's law. This is where the hydraulic energy is converted back into mechanical energy. That's the other side of the arm. So if you have two arms like this, the other side where now this pressure is pushing something up. That's where there's an actuator, right? This is where the hydraulic energy is converted back into mechanical energy, pushing, lifting, etc. Right. So to repeat again, Pascal's law says the pressure applied to a confined liquid is transmitted without loss, no losses, throughout the entire liquid and the walls of the container. But you do realize, guys, that when we are studying here, we're using the ideal, what is it called? The ideal characteristics that is transmitted without loss. But in real life, you know that there's no such thing. There's always going to be an air bubble in the liquid. Right? An air bubble will come, forcing it not to work 100%. So it will have an efficiency of somewhere around 80%, 75%. It will still work, but not 100% perfect. But for the purposes of calculation and simplicity, when we're studying, we use ideal circumstances. Pascal's law, it means that when there is an increase in pressure at any point in a confined fluid, there is an equal increase at every other point in the container. We explained this. So when theory questions come, people should be able to what? To actually model this kind of question. Right? Should be able to actually kill it. I say if there is an increase in the pressure at one point here, right? That means that pressure will be equally distributed throughout everywhere without loss, even to these walls. That's what Pascal discovered, and that's what Pascal means here. Right. I think the emphasis on Pascal's law has been too much now. This basic idea has been too much now. We have covered it. So this is the example that we were talking about a few moments before. That you see, Mr. Sibanda here will come with his small feet and press here, and then suddenly a big car is being pushed or lifted upwards. This is an example of a hydraulic jack. Right. Now we need to come to calculations of these things. Practice. Right. All this we have covered. Right. Now we need to practice with questions. This we've mentioned to the comrades now that the pressure is force per unit area, such that force at the end of the day is pressure times unit area. So what they are trying to say, whenever you have a force exerted on a certain area, force, this is a cross-sectional area, pressure is force per area, right? That's what pressure is. So the greater the differences in the areas of cylinders, the greater the potential force output of the cylinder. Now, watch this. Let's explain this one clearly. Now, watch this. Let's draw it. This is the same thing here, but let's draw it this way. Let's draw another one that way. All right. Same thing here. Same thing here. Right. Now, look at this one. Call it part 2. Call that one part 1. What they are saying is this, that for example here, you're going to have F1 and then you're going to have A1, this side here. Then this side here, you're going to have F2, A2. By inspection, which means by looking, automatically A2 is greater than A1. Sorry. Automatically, by looking, A2 is greater than A1. The cross-sectional area here, A2, is greater than the cross-sectional area there. So if we have P1, which is equal to F1 over A1, which must be equal to P2, which must be equal to F2 over A2. Right. So in order for this pressure here to be equal to that one, that means this force must also be big, so that a bigger area onto a bigger force will give us the same pressure like that one. So the bigger the area, the bigger the output force. You realize, the bigger the area on the other side, the bigger the output force. Hence, this means that the hydraulic jack has a mechanical advantage. You apply a small force here, F1, to get a bigger force, F2, on the other side. This is more like an inclined plane, where when you want to lift something vertically up, it's difficult. But if you roll it up an incline, you use less effort, but you travel a longer distance. Right? That's the same. Here, distance is represented by area, and then effort is the force. You apply a smaller force over a large area to get a bigger force. Usually, F2 is approximately 10 times F1. So if you have F1 here, you have F2 here, you have A1 here, you have A2 here, P1 is equal to P2, as we know. Usually this is 10 times bigger than that one. You use your small foot, that effort of yours is multiplied 10 times or more, right, to give out an output force on the other side, right? That's how a hydraulic jack works, right? So now, there is something that you can go online to see hydraulic jacks, etc. But as I'm going to post the notes also, you're going to find that I will post even websites where you can just click on the link and you can watch cartoons or some videos of hydraulic jacks, jaws of life things. But what I want us to do now is to remember these equations, right? This is what we've been discussing. Now it's being put clear, typed out. P1 will be F1 over A1, and P2 will be F2 over A2. Then by Pascal's law or principle, P1 is equal to P2. And then when you are doing calculations, if you're given F1 and they say find F2, once you see that F2 is not 10 times or more than F1, definitely something is wrong in your calculation. If you find that F2 is not 10 times or more than 10 times bigger than F1, something must be wrong in your calculation. Right? That's usually the case. Unless if they say the hydraulic jack is not 100% efficient. If it's not 100% efficient, then that scenario will be invalid. But remember these equations and remember my tip. I'm not saying that when we're doing calculations, just go and say F2 is 10 times F1. No, do the proper calculation. Sometimes F2 is 100 times bigger than F1. Sometimes 15 times greater than F1. But the principle, list and benchmark is that F1 is always, F2 is always 10 times F1. Right? So remember this, the principle of Pascal and how it works, and you will define all the aspects that we do. All right, this is a repetition. This is also something that we can do as an example. They are saying now, assume a small piston, 1 square meter, right? You are given A1. So usually I like to draw these things, right? I like to draw them like that, so that when you draw something, you always remember. Let's call this side A, right? We call this side B. So let's say A1, area 1, you're given there, right? And then that provides a pressure of 1 Newton per square meter, right? So assume a small piston, 1 square meter, applies a weight of 1 Newton. So we're also given, why is this thing doing this? Right. We're also given F1 on the side. So F1 is, I don't know what's happening to my pen, guys. It's refusing to write, but I have to go to the next page. It's giving me problems here. Next page is written something. Let's do this. We'll come back to that. Let's use this one now. Let's use whiteboard. Right, they said, for example, let's use our own example there. What's going on? My pen is refusing to write. Jesus Christ. Sorry about this, guys. Everything is a mess. What's going on? Everything is becoming a mess. Let's start it from scratch then and see what it will do. It should behave. It should behave. We've started it from scratch. Let's hope it will behave now. Right. Let's hope it's gonna behave now. So I would like us to draw this thing here, right? Put our diagram and then say, assume a small piston. There will be a small piston here, and then obviously a big piston there. 1 square meter area, such that the side of A1 is equal to 1 square meter. Applies a weight of 1 Newton to a confined hydraulic. So F1 here, which is equal to 1 Newton. Right. So which means K1 is equal to F1 over A1, which will be equal to 1 over 1, which is 1 Newton square meter. Right. So they said assume a small piston, 1 square meter area. We put the area. Applies a weight of 1 Newton. We did put 1 Newton applied here to a confined hydraulic fluid, which is here. Then it will provide a pressure of 1 Newton square meter. We did that there. Right. If another piston with an area of 10 square meters, so now we have A2 is equal to 10 square meters. Right. Is in contact with the fluid. That the piston will feel a force. Right. So what will be F2 here? So from Pascal's principle, P1 must be equal to P2. That means F1 over A1 must be equal to F2 over A2, of which F1 we have is 1 Newton, A1 is 1 square meter, and then F2 we're looking for, A2 is 10 square meters, right? So hence at the end of the day, F2 is equal to F1 over A1 times A2, Pascal's principle, such that F2 now will be equal to 1 over 1 by 10, which is equal to 10 newtons. So F1 was equal to what? 1 Newton. F2 is equal to 10 Newton. See, F2 is 10 times greater than F1. Right? Hope that is clear cut. Now, this is another link which you guys can go to, right, and watch and see how this was done there, practice, etc. Right, that's another link that you can go to. Saying explain the diagram, we have explained the diagram in so many ways, guys. It's the same principle. Use this, use a piston, use A1, use F1, use F2, use A2. If F1 is going down, F2 is going up, then use Pascal's principle, P1 is equal to P2, which you have F1 over A1 is equal to F2 over A2. Then you write Pascal's law. Finish and clap. Put your midterm fluid. You are done. The rest is words which follow mathematics, which is there. We've explained everything. Right? So here is another example. Now, this is what I wanted to tell you about. Something to test your knowledge. You see, guys, there was something that Sarah put across that she was asking me. She was asking me that the Menera, but magnetism we hadn't covered it on test one. So, but the marks you asked us there, you tested there. No, magnetism wasn't supposed to be covered in this class because it's supposed to be something that is well known from high school and from primary. But however, I had to cover it because I know that there are some comrades who have forgotten, and I saw that some comrades were struggling. So that's when I had to cover it. So here is another example now. We're doing Pascal's law. I've given you force and area in ATC. But there comes a question where you have to apply yourself. That's why it's called, if you check the UKZN logo, it says transformative learning. That means whatever we are teaching you, you are not going to come across it in life as exactly as it is. We are trying to make you somebody who can what? Who can adapt, who can use the tools that we've given you to learn more and be creative more and solve more problems out there. That's what the logo, the motto of UKZN is all about. Transformative learning. Even you yourself, when you go out there in the classes that you're teaching, you're not trying to teach your students to always expect everything that you give them. That today, if you are not given that, then it's over there. No, you are trying to make them people who become the next Einstein, who become the next Pascal, who will be inventive, who will build upon the other knowledge. So for instance here, what we've been dealing with meters, meter squared, meters, newtons, right? But you will come across a time we've been dealing with kilograms, across questions which now talk about inches, right? Which talk about pounds. Now the weight is pounds, they're talking about length in inches. So you know definitely on your own that you have to improvise now. You have to go to Google or find another source, find out what is 1 inch in terms of meters, the SI unit of length. What is 1 pound in kilograms, the SI unit of mass? Because if you do those questions in inches and in pounds, the answer will be correct. But standard-wise, in terms of learning universally, you'll be wrong because you have to present your results in SI units that anybody from anywhere can understand. For instance, now you don't understand what an OZ is, what an ounce is. If I say that packet is 1 ounce, it's Japanese to you. That's not how we're supposed to do things. You're supposed to now know how to convert ounces to what, inches to what, right? But no one can teach you that. No one can teach you that. This is basic knowledge from primary that we're doing, that 1 centimeter is equal to maybe 10 millimeters, etc. Then from there, no one is going to teach you that. It's basic knowledge that you have to apply for yourself. We're going to give you the tools, but the big chunk is up to you now to go out there, study, push it. Because the more I give you 10 inches, and then I give you 1 inch is equal to 2.54 centimeters. Wow. Next time when you don't meet inches, you meet yards. What are you gonna do? You're gonna want me to convert yards for you so that you can work out your question. That doesn't work that way. So that's what I was explaining to her the other day when she wrote me saying, but I was like, no, you see, Sarah, I understand where she's coming from, but some things I can't dwell on them because my syllabus concentrates on other things. That's when I go an extra mile when I see that the comrades might have a problem here. Then I can go an extra mile and say, no, let me a little bit shed some light there. Same as with the issue of digital electronics that we covered. Right. I first had to take you through binary numbers, right, and then take you to logic gates and logic functions. Right. But someone, if they're given this course, they won't bother taking you binary numbers and the addition of binary numbers. No, they'll just shoot you straight to logic gates, functions, and etc. And then when you go out there to your schools, you'll meet some clever students. They'll start now wanting to link the binary number 1 zeros to the logic gates. Then you'll be stuck not knowing where that came from. Then the other one will start wanting to leak now where the binary comes from, that it's digital to analog. But you won't have that basic knowledge if I didn't say, okay, let me go an extra mile and cover the comrades here so that the understanding becomes easy. When they meet someone, a student who's inquisitive, they can now blow their minds, right? So it's like that, guys. Some things is general knowledge from there. Same as with the explanation here. You will meet inches, you will meet pounds, you will meet yards. Find out on Google how these convert to meters, kilograms, to SI units. Right. Anyways, this is now a repetition with an example that I was showing you. That, for example, look at this one now. They are applying a force of 100 lbs here. See, now we're talking about pounds. And then the diameter here is given in inches, right? And then you see the diameter here is also given in inches. We're expected to find F2. So you must find out that F1 will be equal to what pounds and what in terms of newtons, right? Then these inches, you have to find out area is going to be pi r squared, right? And then you're going to have 1 inch in meters so that you put in and find your area there. And then area 2 there, pi r squared. It will depend on these 6 inches, but we don't use inches. We use meters as our SI unit. The whole world standard SI unit is meters. These inches, pounds, this is American or British, I don't know. So you're going to have to be careful when answering those questions. Because mathematically, if you keep your working using these things, mathematically it will be correct. But standard SI units wise, it's not. So here is an example concerning this question here. Here is an example which says to determine the multiplication factor in the figure above. Start by looking at the sizes of the piston. Assume that the piston on the left is 2 inches in diameter, right? That's what we saw here, 2 inches here. It's 2 inches, then the other one is 6 inches, right? So to do, what you need to do, you're going to have to calculate the area of the 2 inches. You see, they're already giving you 1 inch is 2.54 centimeters. How do the areas compare in size? Obvious, A2 is greater than A1, right? What does this imply in terms of the force applied to the left-hand position? Simple, we said it. If A2 is bigger, which means F2 is also bigger than F1. Pascal's principle. If you apply the 100-pound downward force to the left piston, what will be the upward force? Approximately, I'm guessing, note that is that F2 will be F1 times 10, right? But you can do the proper calculation using F2 is equal to F1 over E1 by A2. This is the proper calculation. You get an answer, but approximately supposed to approximate to that. And then what is the catch? The catch is that we're applying a small force per small unit area, right, to get out a bigger force on a bigger area, right? That's working smart, isn't it? That's what we want machines to do for us. We want a machine to make the work easier, right? That's why we use a long crowbar to open. You see bus tires or truck tires, they're bolts. Have you seen how they take out this nut? They use a long ratchet, which is a long handle there, because class one lever, small effort, bigger force on the load. See, same thing, want our machines to do the work for us. We want to apply a small force to get a bigger force. So this is an example. If you made pounds and inches, how you gonna go about it? Convert the inches to centimeters, convert the lbs to kilograms and newtons. This is the same thing that we've been talking about. Here is example 2. Right, the pistons of a hydraulic press have a radii of 2 centimeters and 12 centimeters. So you know that now we have R1, which is 2 centimeters, which is 2 over 100 meters. Then we have R2, which is 12 centimeters, which is going to be 12 over 100 meters. Right. So they are saying what force must be applied to the smaller piston to exert a force of 5,000 newtons on the larger piston. So they gave us F2, which will be equal to 5,000 newtons. Now draw your thing. There is our normal diagram. Then we come here, small piston, large piston. F2 here, we're given it as 5,000. F1 is what you are looking for. Right. So now let's calculate the areas. The cross-sectional area of a piston is round, right? So it's exactly pi r squared, right? So A1 is pi r squared, which is pi times, what is radius 1? 2 over 100 squared. And then area 2 also is pi r squared, which means it's going to be pi 12 over 100 squared, right? So you have those two. So now to calculate F1, remember P1 must be equal to P2. F1 over E1 is equal to F2 over A2, implying that F1 is equal to F2 over A2 by A1, rearranging of this formula, right? F2 were given is 5,000, A2 we calculated here, E1 we calculated there, then punch in a calculator, you get F1. Clear cut, right? Any problems there, comrades? Now this is your time to shine, guys. This is the time when you say, Manera, there, I can't understand, there's a problem, and then we repeat things. So that when you come to SU, you just get 20 marks for free on hydraulics. And your home dry, you only need now 30 to get to 50. So shine, comrades. Ask where you don't understand, and let's explain to the comrades. So is that clear so far? Right, the comrades are quiet. Then that means things are clear.
Yes,
And then
yes, sir, it is clear.
someone says, please repeat that example. All right, we will repeat. So next week, Thursday, will the test started the lecture time for Thursday, which is 12:10. Yes, we're going to start exactly at the lecture time. We're going to start at the lecture time. But we wrote that we are given the venue from 12 o'clock to 2 o'clock. All right, we're given the venue from 12 o'clock to 2 o'clock. All right, guys, now that we've answered Hannah, Ntogozo said, please repeat. Finally said you were too fast. And Ntogozo also said, please slow down. All right, we'll redo this question again. But I want you to remember this because I want to go to white space, right? I want to use the white space because that is not clear. Let's use whiteboard, right? So we are given, we are given R1 as 2 centimeters, right? Which we convert to meters this way. It's 2 over 100 in terms of meters. And then we are given R2. Where is undo? There is undo. And then we are given R2 is 12 centimeters, which is equal to 12 over 100 meters. This is going to be 0.02 meters. This is going to be 0.12 meters. Right. And then we are told that F2 is equal to 5,000 newtons from the question. And then we are told to find F1. Right. So we said, let's draw how our problem looks like. This is piston 1 there, this is piston 2. This is where F1 is applied going down. This is where area 1 is. This is where F2 comes out, which is 5,000 newtons. Then this one is going to be area 2. Right. So we said now that Pascal said the pressure applied from the smaller side is equally distributed throughout the medium, such that it becomes the pressure on the other side. Hence, P1, let's undo, hence P1 is equal to P2, right? So once we have established that P1 is equal to P2, this means that F1 over area 1 is equal to F2 over area 2, right? But then we can calculate area 1 and area 2. Area 1, we're given radius 1, is pi r squared, right? This is side 2, isn't it? So which means it's going to be pi, that radius squared, which is 0.02 meters squared. And then area 2 is going to be pi, right, r2 squared, which is going to be pi 0.12 meters squared, right? Then to get F1 now, we rearrange the formula to make F1 the subject, such that F1 is going to be F2 over A2 times A1, right? Of which now, let's go, F2 we're given is 5,000, right? A1 we're given there, we calculated. A2 we calculated. So punch these values on your calculator, you get your value for F1. Right, clear now.
Yes, sir.
Wonderful. Now, if it's clear, comments. Slindile, you have to know the formulas, but I'll give you a few of them. But if you don't understand them, it will be just your waste of time. I can put a few formulas, a formula sheet. I can supply you with a formula sheet, no problem there. I can give you a formula sheet. But in my understanding, the way I was taught is that the formula sheet always wastes your time. You browse through to open the formula sheet, go back now to answer, go back to the formula sheet, go back to answer. You have to think also, so your time. If you practice and you get to know these formulas, it's easy to go faster, but I'll provide you with the formula. Anyways, in real life, you don't need to claim formulas. In real life, you're just gonna go to Google or wherever and check out your formulas and then work it out, right? So I can provide the formulas. So now, part A of the question has been done. Now let's go to part B. All right, we've done part A of the question. So now let's go to part B of the question. So now I have to go and find it again, comrade. It disappeared. Sorry, this is not the one I want to put. Accidentally put this one. So let's go back to part B of the question. Right. Skip, 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 yeah. So we are here. Part A is done, right? So now they are saying, what is the pressure on each piston? That's easy. F1 over A1 is equal to F2 over A2, which is equal to the pressure. Pascal's law, remember Pascal's law. So you have F2, you have A2. We calculated A2. Punch on a calculator, you will get that. So that is 5,000 newtons over A2 was pi times 0.12 squared, right? You will get P. You get your pressure. Remember, we calculated A2 as pi r squared, which was pi 0.12 squared. Our F2 we're given is 5,000 there. So pressure is F2 over A2 equal to F1 over A1 by Pascal's law principle. Hence, you get your pressure, right? And then they say, what is the mechanical advantage? Right. So, mechanical advantage is equal to load over effort. Right. The force load over the effort force. So to make things easy, we will do it this way. We will find F1. We say F1 will be equal to F2 over A2 times A1. Remember? And then we say F1, which means will be 5,000 from the white space newtons over pi 0.12 squared times area 1 was pi by 0.02 squared. Right? So pi out, right? And then now we're left with F1 is equal to 5,000 times 0.02 over 0.12 squared. You guys have a calculator, punch in the values and tell me what F1 is. I don't have a calculator. Let me see. I have to use my phone now. You see what I'm talking about, comrades? You are depending on me to calculate, but you have a calculator there. You won't learn when you do that. You will always be in trouble. You see, still no one has put an answer there. Matata. How are you going to answer it then if you are waiting for me? I won't be answering that day. So that would be 0.02 divided by 0.12. So F1 is something like 138.8, which is approximately 139 newtons. Right. Let's see somebody had said something here. The comrades, yes, thank you, comrades. 138.89. So now that we've found F1, right, let's find the pressure. We say the P. So part A has been answered, right? Now let's find part B. P is going to be F1 over A1. So which means it's 138.88888 over pi 0.02 squared. So punch. Also, somebody else do this one. Say pressure is equal to F2 over A2, which is equal to 5,000 over pi 0.12 squared. Someone also punch this one. Should give us the same answer or approximately the same answer. What is the answer, comrades? Please punch in the calculator and tell us. I don't have a calculator here. Anybody? Okay, I'll try and do it myself now. So that means that will be. Let's see, anybody who is punch, yeah, somebody is such that P, they say P is equal to what? Let's go and look. Somebody say P, somebody is punched also. Right. 110,524. Right, thank you. 110,524. 110,524 point something something. Right. So see, easy peasy, pressure has been found. And then now, what is the actual mechanical energy? Part C. Now, MA. Right. There is a difference between actual mechanical energy advantage and mechanical advantage, as you're gonna learn. But MA now is equal to load over effort. Now, we have our diagram like this. It says what force must be applied to the smaller piston to exert a force of 5,000 on the larger piston. So which means this is output, is F2, then F1 is input. So hence, that's what effort, input, the force that we want to apply, this is load, right? English. So MA is load over effort, which will be 5,000 newtons over 138.9 newtons, right? Which you will get something like what, comrades? Get something like 35.9. Right. So this is a very, very, very good machine. It has a really good mechanical advantage. Right. Simple and straightforward. So for instance, if someone says, someone gives you and says a machine has a mechanical advantage of 1, what does that mean? If someone says it is MA is equal to 1, so that machine is not good. Load over effort are equal. You apply a bigger force to lift a bigger force. That's a bad machine. You see that? But if someone says the MA is equal to 2, that means load over effort is equal to 2. That means 2 times the force, 2 times of the load is lifted by an effort. Right? The bigger the MA, the better the machine. The smaller the MA, the better the machine. All right, comrades. Let's see on the charts. Someone, okay, they were giving us an answer. That's good. And then that's it, guys. Nothing much on this. You expect such a question, simple and straightforward. Nothing hard, nothing weird. So here is another example here. They're saying a man weighing 60 kilograms is standing on a wooden plank, which is 0.5 meters by 0.5. Find the pressure exerted by the load on the ground. Basic stuff is I was telling you, that's some things I expect you to should have covered them a long time ago, because this is electricity and electronics course. Pressure and hydraulics come in because they have electricity a bit on hydraulics only. But the other things you should have learned. For example, here, they want you to find the pressure. We know that pressure is force per unit area. But we're given mass, which is 60 kilograms. So we have to find weight, which is a force, which is equal to mass times acceleration of gravity, which is equal to mg. So weight here is 60 by 10, right, g. That means W is equal to 600 newtons, right? And then now we need to find the area, which area is 0.5 meters by 0.5. What's the answer there? That's 0.25, ne? I don't know, 0.5 by 0.5.
0.25.
Yeah, 0.25 meters. Such that at the end of the day, P is 600 newtons over 0.25 meters squared. That should give you what? 600 divided by that. What's that?
2,400.
3,400.
2,400, sir.
2,400. See, guys, No one is going to teach you that you have to convert this mass into a weight. This is general knowledge that you're supposed to know, that there's a difference between mass and weight. Right? Weight is the force applied by your body by the Earth's gravitational force. Then mass is just your quantity, the quantity of your body, but force is different. So pressure is force per unit area. Convert your mass to force, divide by area. You get your stuff. Clear cut. Clear, comrades. Now let's check on chat if there's someone who has problem. No, it's output force.
Yes, Mr. Mr. I'm here.
Yeah, and ask a question.
All right, if I may ask, Mr., why did you use 10 instead of 9.8, where there is mg there?
That depends on you. The real value for proper calculations is 9.81. It's 9.81 meters per second squared. Right? That's the real value that is. But for calculation purposes, are you able to play around with numbers with commas? If you're comfortable with that, you can use that. But if you read textbooks and check, they are saying on calculations, we approximate it to 10 meters per second squared. But if you're comfortable with 9.81, it's fine. And
all
then,
right, Mr. Thank you very much.
All right. And then somebody had asked a question before I forget on chat. Someone said G is equal to 10. That one we have explained, 10 for convenience. Say what's the unit of pressure? That's Newton meters. Newton meters. Right. Newton meters. You can actually use pascals if you want. 1 Newton meter is equal to 1 Pascal. Or you can use atmospheres. Right. But for your calculations, Newton meters. Newtons per meter squared. Right. Area. You can use pascals, P, you can use atmospheres, but atmospheres is used when you're dealing with gases, right? Pascals is used when you're dealing with fluids. So either way, if you use pascals with me, I am fine. If you use atmospheres, it's like you're dealing with gases, so it doesn't apply. But if you use F, which is Newton over meter squared, which is Newton per meter squared, it's still fine for SI unit. I have no problem. This you can use, this you can use. But atmospheres are for gases, right? And then there was another question there on the chart. Just go and see. Okay, say blah, blah, blah. And what else? I think I forgot. Oh, Hannah, I answered her. And then, right. Now, let's see the hands there. Bonambi, your hand is still up. Okay, now there's Kanyile. Kolani, you can go ahead.
Okay, so you said something when we're explaining to us when we're exploring calculations on actual mechanical advantage, and then you said there is actually a difference between the actual mechanical advantage and mechanical advantage. Can you please explain that difference?
Right. So this thing is put like this. There's what is called just mechanical advantage, but this is not part of your course, but for learning purposes, is what is called just mechanical advantage, right? And then there's actual mechanical advantage. Then there's IMIE, right? So mechanical advantage, this is when you're dealing with ideal situations. Ideal situations. That means you're assuming no losses in your system. This system of yours, there's no losses. So if someone says find the mechanical advantage, right? They say the system has no losses. But if they say find the MMA, actual mechanical advantage, now that's a different story. They would have given you that your machine maybe is 75% efficient or it's 80% efficient, which means there are losses in there, right? So whatever you are calculating, your input and output, there will be losses on that system, right? So actual mechanical advantage is when you're given a real life situation which has losses in there. And then there's something that is called IMA. This is velocity ratio, right? Velocity ratio, but this is not part of your syllabus for this course. So MA is just load over effort. Then AMA, right, is load over effort by 100, right? It's actual, it's influenced by the efficiency, E. So if you're given efficiency of 75, use 75 there. Efficiency of 50%, use 50% there, right? So if it's an ideal situation, you use 100. Hence, that's why here we don't use 100, we just say L over E. This one is influenced by the efficiency of your device. So when you are writing MA ideal situations, load over effort, then AMA, this one is losses, that's L over effort by efficiency, right? That's the two differences there. This one is influenced by the efficiency of the device. This one, ideal situation. Any other questions or clear on that part? Comrades, I'm waiting.
It's clear, sir.
Someone is answering towards say clear. Anyone else with a question? So homework. The
No,
hydraulic,
everything is clear.
the hydraulic press is an input cylinder 2 inches in diameter and an output cylinder 6 inches in diameter. Assuming 100% efficiency, you see now how the question comes. Find the force exerted by the output piston when a force of 10 pounds is applied in the input piston. So what they are saying now, that there's 10 pounds going in here on the smaller piston, which is 2 inches diameter, and then there's output force F2 there, 6 inches diameter. So you have to go and change, right? T1 is equal to 2 inches, which is equal to 2 by 2.54, 2 times 2.54 centimeters. D2 is equal to 6 inches, which will be 6 by 2.54 centimeters, right? And then that change it to meters, that to meters. Then come here, the input force is 10 pounds, convert 10 pounds to newtons. And then after that, do your thing. F1 over A1 is equal to P1, which is equal to P2, which is equal to F2 over A2, right? Then here you're looking for F2, as we said, F2 is F1 over E1 by A2. And plug in your values, calculate. Easy peasy. So now this is your homework to do on your own and see how far you will go. But I've just given you a pointer there in seconds on how you can attack it when you are alone at home. Right. And then we come to one important question that is always, say, are we allowed to use phones as our calculator? No, you can't use your phone in an exam or test. You can't. But anyways, the questions that we're going to be doing, you can multiply by head. If you want to use a calculator, that's an advantage. You can use your head, it's fine. But for major tests, there will be no calculator. The questions will be simple, straightforward, that you can calculate. Just multiply 10 by 500, 500 divided by 20, easy things. The phone is not allowed in a test venue, no matter the circumstances. It's only except when you are writing online that we don't see it. Now, guys, there's something important. One question which is always there in many exams, which I want to tell you so that you go and read about it, you claim it, you whatsoever. Most of the exams, this question is never missing. It's never ever missing. It's always there. So, rounding off or not rounding off is fine. I don't care. You can round off to 1 or 2 decimal places or whatever. It's fine. I'll know. It's okay. Don't worry about that one. And then there was someone raising a hand. Vincentia, you can go ahead and speak.
Sir, you said if it says 100% efficiency, it means that the hydraulic is
It's ideal. There's no losses.
Oh, okay. All right. Thank you, sir.
All right. Now, if there are no other questions, let me give you a pointer on this important question. This happens in real life. I'm sure you use it, but you don't know that you're using it. All right. How do hydraulic brakes work? The brakes of your car. How do the brakes of your Quantum work? The brakes of a car that you drive work. So this is where what we have been learning comes into the picture, right? You have your small foot or my small foot, you just put it on the brake pedal, and the big car or big truck, SUV, whatsoever, eventually comes to stop within 200 meters or 100 meters. How come? How can your small leg brake a big car? Right. So this is how it happens. This you only don't need to calculate. You only need to know the explanation that I'm going to give you now. So that one, don't worry about the application. How you calculate and how you what you're going to meet it on other courses. Or you've met it already in another course, I'm not sure. But you want to meet it maybe, I don't know, maybe we're going to meet again in EDSE2 or 1-2. Right. So let me remove this. Do I have a picture of the braking system here to show you? Yes, there it is. So listen to the explanation, because usually it comes in the form of theory that you're writing sentences. So how does it work? There are two things that are involved there, two principles, 1 and 2. The first one is the moments. I don't know whether you've learned moments before or you've never learned moments in high school. And it's the principle of moments. And then the next one is the Pascal's principle that we're learning today. What's going on today? My pen is not writing. Pascal's law. Right. So what happens, guys, here is you have your foot, right? Your foot comes here on this pedal, right? That's where you apply your pressure or your force or your effort. And then using the principle of moments, your force here is amplified by principle of moments. Principle of moments. When it is amplified by principle of moments, it then comes to the hydraulic brake fluids. You know that there's brake fluid, right? That's the hydraulic system that uses Pascal's principle. So your amplified force comes here, it becomes F1, and then it is multiplied 10 times or more and becomes F2. Then that F2 from Pascal's principle goes to your brakes of a car. Then the car stops. Simple, yeah? Part 1, principle of moments. Multiplies your force, your foot force. And then secondly, Pascal's principle. Your force from there becomes F1 there. Then the hydraulic machine of brakes amplifies it by 10 times or more to become F2, Pascal's principle. So that means your force which has been on your foot has been multiplied by almost 100 times. Hence, it comes to your brake pedals, which are for both wheels, equally. Right. So that's how another example of the hydraulic machine is the hydraulic brakes of a car. Right. So usually that's why we say we're using ideal circumstances. Imagine if there was an air bubble in here. That would be a big problem. You've heard of the thing that the brakes failed. There was brake failure. That means this cylinder here at the hole, right? Such that now when they're trying to compress and use Pascal's principle, it was not working. There was now air. And air is compressible, so brakes don't work. That's brake failure, right? Usually it's because the cylinder would have rusted, have a hole or something. So that's one question which usually comes as theory, and I've just given you the answer. It comes, you give the exact answer that I gave you right now, 100% of those marks will be used. Otherwise, comrades, I have come to the end of today's lecture, and I've come to the end of covering many things. So what's left now, comrades, is for us to revise, right? What's left is for us to revise. Someone asked somewhere on chat, don't you have it in a written form? Say that, my friend, is called spoon feeding. This is what I was talking about. I cannot do everything for you. What's your job then? Because the way you are asking me now is going to be the way how you teach. So the way how you raise your students, that's the way how they are going to be out there. So if I explain to you in English right now, and I'm going to upload the lecture video, but you still want it in written form from me, what's your job then? Marinate yourself on Google. It's there. That's why I told you. That's why I even gave you a hint, right? Because I want you to go out there on Google and look at it. It's there. Even right now, when I'm typing on my laptop, I can see it, that question. Just say hydraulic brakes of a car. You will get every information you want explained nicely. You have to have a homework also. So anything else, guys, but otherwise, if not, we are done today. You guys can marinate me when you want us to revise. I also will announce when I feel like I need to make you aware of something, but so far so good. What's coming next is the assessments and the revision. So I'll stay here for a few minutes. Those who want to ask can ask. And then those who want to go, have a lovely weekend. We will meet next week and go prepare for the test. Have a great one. Enjoy, 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 enjoy.
Thank you.
Thank you very much.
That's wonderful, guys.
Sir. Ntokozo uma on-camp awufike la endlini. Uma on-camp awufike la endlini.